Hi everyone, welcome to my channel. My name is Ashish Pandey and thanks for watching this video. First thing first, for the people who have interview coming up and came to my video looking for the solution to the problem, please feel free to skip this section and jump directly into the problem discussion, and all the best for your interviews. For rest of us, as you might observe that this is the first video on this channel, so I wanted to have a short discussion about the channel, why I have created this channel, what are my goals from this, and what I'm planning currently from this channel. So basically my whole intention towards making these videos is to build intuition towards solving problems instead of directly jumping into solving them. I feel like jumping into the solution during the preparation phase does not help when an unknown problem is asked during the interview. And if you don't have any intuition of solving difficult problems, it will be harder and harder to solve during the interview in that amount of time. Uh, in order to achieve better intuition, I'll try to cover multiple solution after doing research and cram. I'll try to cram all that information into a single video, so you guys don't have to go on searching for the efficient solution to the problem which interviewer usually expects from you during the interview. In general, I feel like this will help you guys as well as me to succeed in the future coding interviews, and in the process will become a better developers. That being said, let's jump to the problem that we have today. That is a two-sum problem, and that is a lead code problem. It is one of the highest liked problems in lead code, as you can see from the number that is here. And in this problem, basically, we are given two inputs. One of the input is the array of the integers, which is called nums, and there is another integer that is target. And we have been given that like there will be two numbers in that integer array. They will add up to the target value, and we have to return the indices of those numbers. We don't have to return the numbers, we have to return the indices of those two numbers. And one reason I feel like why this problem is categorized as easier, because there is like certain restriction that has been given, and which makes this problem easier, and which is explained in the next two lines. It says that you can assume that each input would have exactly one solution. So we are for sure that there will be one solution. It will not be more than one, or there will not be any scenario when you don't have any solution. And another thing that it says is that you may not use the same element twice. So what it means is that you don't have to return the same indices. It doesn't say about the value uh, of those integers. The value of those integers can be same, but the indices of those integers should not be the same. And the other thing is that they have made it easier to follow is you can return the answer in any order. For example, if your answer is first index, second index, uh, and if you are returning output as second index comma first index in the list, it will always be accepted. So if you look at the example one in the problem, we have been given a nums integer array that is 2, 7, 11, and 15, and we are expected to find the indices of the numbers which will add to the value 9. And we can see this number 2 and 7 which are adding up to the value 9. That's why the output is 0 and 1, which are the indices of the 2 and 7. As you have observed, we can output 1 and 0 also, and it will be accepted as a solution. And the second example has like another array of integers that is 3, 2, 4, and the target value that is expected is 6, and which is coming by summing the value 2 and 4, and that's why the output is 1 and 2. These are the indices of the value 2 and 4. So I hope the problem is clear as of now. So if we move on to next section, is that lot of companies usually ask people to ask more clarifying question after the interviewer has told you the problem statement. In this case, problem is very tightly coupled, so I can think of one clarifying question that you can ask to the interviewer is what is the expected time or space complexity, which one should be lesser? Either it should be space complexity should be least or the time complexity should be least, and depending on the answer that interviewer gives, you can give out the response accordingly, and I have covered both the solution in the next slides. So if you look at the first solution, which is the easier one and more intuitive one rather than the second one, and which is the least space complexity. So in this one, the intuition is basically you have to find two numbers. So you will be running two loops. To one loop, each loop will be finding each number, and we'll check all the iterations, and whenever we find the sum equal to 9, we'll return the output as those indices at which we are able to find the uh, target equals to that value that is given. So first we'll run this loop that will go from 2 to 15 or 2 to 11. Both of them works fine. And for an efficient solution, you can go from 2 to 11. And the second loop will be going from the one index above than the first loop's index. The reason behind is that they are not expecting the same indices to be as an output. So we have to find a different indices. That's why we have to add one to the indices of the first loop. So if we are running the first loop, it will go from 2, and for that index it will go from 7, 11, then 15. And in the second iteration of the first loop, it will select 7, and then it will go for 11 and 15. But looking at the problems, the example that we have, it will not go that far. It will be just picked up in the first iteration of each of those loops. For example, for the first loop, it will find the value 0, which is 2, and for the second loop, first value it will find is 7, and if we sum both the values, it will come out to be 9, and which is the answer, and will return 0 and 1. So in this way, as we can see, you are just running two loops. You are not saving any data for the problem when the loops are running. So that is why this is a least space complexity solution. And if you look at the another solution which is more better in terms of time complexity, so we'll have to look at this problem in a different way, rather than looking at one loop finding the one value that is A and another loop finding another value that is B, and then summing it up and then trying to find the target value. And if the target value matches, then you return the indices of A and B. But if we uh, turn it around a little bit, this equation, mathematical equation to B is equal to target minus A, then in that case we can utilize the hash map to save all this information that we are getting during the loop, and every subsequent number will check against whether it's in the hash map or not. If it is in the hash map, and if we sum those values and we get the value 9, then basically that's where we have found the solution. It's not value 9, it can be target value, whichever is passed. So so we'll have like one loop that will be going from first index to the last index, and every time it sees a number, it will try to find it into the hash map by calculating the value called target minus number that is it is right now, which in the first iteration it will be 2, And if it is not existing in there, then what it'll try to do is it'll insert that number into the hash map with the index of that number. For example, in the case of 2, it will store the value 2 as a number, which is a key, and the value will be the index value, which is 0, as you can see here. And in the second iteration, when we go to the 7, it will try to look for the 9 minus 7, which is the value 2, and it'll find in the hash map, and it'll try and that's where the execution will stop for that solution, and it will return the value as 0 and 1, because 0 it will get it from the hash map, and the 1 value it will be getting from the current uh, number, that current indices that we have, and it will shut down the um, program at this point. Now let's go and solve the problem in the LeetCode itself. Let me refresh the page. So it's refreshing now, and let's start writing the first solution. So here we'll be going for solution 1, and then I'll write the solution 2 in here, which is least time complex. So one thing that can be utilized by both the solution is the length of nums. So if I'm writing the first solution, I'll be having two loops. First loop will be going from 0 to L nums. If you want to be more efficient, you can subtract 1, because second loop will cover the last number, and second loop will be starting from I plus 1, which is the index of the previous loop, and then going till the last, which is L nums. And for every iteration, we'll be checking it whether it has find the solution or not. So what we'll try to do is I'll check the value num I and nums j, and if it is equal to target value, then I'll basically return I comma j as an index list, and that should solve the problem from the solution 1. So if we run the code, and if I use all the example test cases and then try to run the code, it gets accepted. If I submit the code, it gets accepted, but you can see that it's not very fast as of now, because it's taking 21%. It's faster than only 21% of the people that has submitted the Python submission. So if we go back again and we comment this part out, and we try to write the second solution, so there I'll need the hash map, and which is nothing but a dictionary, and this time I'll be just running one loop that will start from first indices, and it'll go to the last one, and if I'm not finding the value target minus nums I, let me make it as value a, so that will be easier to address. So basically I'm trying to find the target a in the hash map. If it is not finding that value there, it will insert the value as this hash map a will be index I, and in rest of the cases, because it will find the value in there, so it will come to else, and in that case we know the value it has been found, so we just have to return the value of the indices, and we'll, because we have stored the index as the value in the hash map, so I will, from this statement, I'll get the value of the index of the first one number, and the second number I'll be able to get the index that is the current number. And if I run this, because again we'll have a unique solution, so I can just return as soon as I find the solution, so I don't have to write another statements there. And if I run this, as you can see, it's accepted, and look at this number, it will be much faster than uh, this one currently, because it's using the hash map. So as you can see, now it's faster than 64% of the people who has uh, completed this solution in Python. So this is the solution that we have created, and as we have discussed in the slides. Let's go back into the slides, and thanks for watching this video. uh, I hope it was helpful, and if you like the video, please like, share and subscribe, and if you have any feedback, please feel free to share through the comments. And if you don't like the video, uh, please provide a feedback so that I can improve upon next time, and I can get the like from you. That's it. Thank you guys. Bye bye.